Hello, Connor here. This is my video for my team's MEC-120 climbing robot project. The goal of the project was to create a robot capable of climbing the ladder by touching every rung between the fourth and the top. The robot was required to do so using a pneumatically powered system. Here, you can see our robot successfully complete this requirement at 2 times actual speed. My partner and I used all 4 of the provided pneumatic cylinders to create an arm-like pull-up climbing system. As the idea required that the 2 arms remain independent of each other, supporting them became the hardest challenge of the project. 3 pairs of gears were used to help maintain the robot's stability during the climbing process and to help anchor the smaller arm cylinders in place. The actual design of the robot did not change greatly during the entire process. The original 4-cylinder concept was merely outfitted with additional supports and tweaked as changes became necessary. One of these tweaks included the adjustment of the cylinder's height by remounting the component higher up on the robot. As you can see, the design is not intended for speed. As an additional challenge, students were offered the chance to receive extra credit should the robot be able to descend the ladder in a controlled manner. Although it was never implemented, this robot was designed to be capable of doing so. The biggest adjustment that could still be made to the robot would be extending the smaller arm cylinders' reach. Moving them forward even a tiny amount in their holders would greatly decrease the chance that the robot would slip and thus fail. Here is a look at our motion and control diagram. It has been broken up into 2 parts to distinguish the different operations of the robot. The first part, the initial sequence, is demonstrated here at normal speed. This is only executed once per run, and it allows the robot to set up the primary climbing sequence that can be then repeated until the robot reaches the top of the ladder. As previously mentioned, the robot's design changed very little over the course of the project. Here are some of our early diagrams as well as photos of the robot during the build and the test phase of the project. The fluid sim perspective has similarly been broken up into 2 parts. This first part is a video of the computer monitor showing the full initial sequence and 1 full pass of the climbing sequence. Once again, this portion has been sped up to 2 times speed for viewing purposes. The second portion of the fluid sim perspective is a full example run-through of the climbing program recorded on the computer running the program. Notable changes have been made on the input configuration side to allow the program to run without the easy port. 24-volt power supplies have been added to the fluid sim program in place of the physical power connections that would normally be present. In addition, please note that this section has been sped up to 4 times speed for viewing purposes, as it is the repetitive process of the full climbing routine. I hope you enjoyed the video and thank you for watching.